Hi everyone. Today we bring you to our weekly insights on creating terrain model using LiDAR point cloud data. If you are not familiar with the Bentley legacy product and their interface, I suggest you watch the video which explains you about the interface of ORD. Capricorn, it's a Win Zero company and a partner of choice for AEC industry. Is one of the biggest platinum partner of Autodesk and Bentley, along with the authorized training center. We have 300 plus dedicated team members, sorry, with client age of over 20,000 in AEC and associate industry. Let me introduce myself. My name is Viraj Deshmukh, Solution Specialist, Roads and Railway at Capricorn Technologies, Delhi. We'll be presenting you with today's. Today, the features which we are going to cover in this insights are how to attach a point cloud data, how to view that point cloud data, create terrain model from that point cloud data, attach a raster image if you have, then create a break line in point cloud data using snap or snap element tool or place fence. And we will add this point cloud break line to our terrain model, which is made up of point cloud. And then we'll combine two terrain. We'll see in this insights. So after opening the software, we'll set a workspace and work sets depending on which units you are going to work. And let's suppose say I'm going to work in Imperial, sorry, in metric. Then we'll open a file, which is uh, which is an empty 3D design file with appropriate geographical coordinate system defined. So we'll open this file. We'll attach this metric TM point cloud data, which is an empty 3D file, 3D design file, as I told, with the appropriate geographical coordinate system defined. As I said, the file is an empty file. After pressing fit view, nothing is there. The geographical coordinate system is already set up. Now, next, we will try to attach the point cloud data. We are going to bring in the point cloud data. Software can read many different point cloud formats. We'll be using point cloud data store in .pod file. So we'll go in our reference tab here, point cloud data from a file, attach, and we'll attach this BWC mpod file. As I said, it's in a .pod format. So we'll hit open. As you see, the point cloud data has been brought in. The point cloud data here will use to supplement the field survey data. So now we'll attach field survey data also in over this point cloud data later. This point cloud data can be visualized in many different ways by using the preset point cloud style. To change this preset point cloud style, we'll go in view attributes here in the left corner of our window. At this bottom, will currently it is set to none. We'll set it to classification and intensity. So you will see the point cloud data gets changed, and as I rotate it, you can see the point cloud data is now brought in. Now we'll again shift it to the top view, and the point cloud style provides means of this point cloud style provides means of visualization of the point cloud data, so that we'll came to know what is there in our data. It helps us to determine what we have in point cloud data, that is tree or buildings or something with different colors and notification with different class and intensity, we can say. We can see the different colors of classification of their types and their intensity. To change the point cloud data style, we'll go to intensity, we will go to wave attribute tool, and we can change, as I said, we can change it from here. So we'll now there can be seen under classification and intensity the different settings of what can be seen and what colors they are specified in. So we'll go in this ellipse or three dots on the right side. So the property panel will get open of this here, as you can see. We'll pin it up here, and as you can see, there are high vegetation, low vegetation, the different notification or intensity given to this point cloud data. We'll turn it off all except the ground one, because we need ground one to create the terrain model. As I said, we're going to create a terrain model from this point cloud data. And after toggle it off, we'll attach the field survey terrain model to this file so that we can see the limits of the field survey data and see how that relates to the point cloud data. Later, we'll combine that survey terrain and this point cloud terrain, which we'll create now, and we'll see the complex combined terrain. How to combine this complex terrain. First, we'll create this terrain from point cloud data. As you can see, the left out will be only red color, ground one, and everything will be off. As I don't need to create terrain from low vegetation or high vegetation, I need to create terrain only from the ground, only from the ground points which are at ground level. So now, yes, now it's can be visible. So, so we'll attach a terrain model created from survey files. It's a DGN survey file, simple. So we'll attach this survey metric TM survey DGN file. The attachment method will coincident world open. And as you can see, I hit fit view. The terrain model has been attached to this point cloud data or to this DGN file, we can say. So I want to bring the survey also. So what we'll do, I'll go to the same attachment tool, attach, and fortunately my terrain survey is also attached in the DGN file, created in the DGN file. So I'll attach this survey also, same. So now you can see my terrain also is the survey points are also there. So this terrain is created from this point survey points, and now we'll create a terrain from this points which are LiDAR point cloud data. So before that, we don't need to create this much bigger terrain, as our survey data is only, as our projected area is only this much. So I'll place a fence to create a terrain model, so that to my terrain model will be less heavy. It can be easily used. So we'll go in, we'll change our workflow to survey, or we can go from here also to in the drawing view. We'll place a smart line. The segment is line and the vertex is sharp. And now we'll place a line here. As you can see, the line is placed here. sorry, by mistakenly I have placed the smart line. We need to place a fence in place of the smart line. So placing fence, you will use this command in same drawing, selection and place fence. I have used drawing, placement and place smart line. So that was my mistake. I'll place a smart fence line. So to place a fence line, the type is block. I'll use a shape and I want the fence mode is inside. That whatever I will create, the it will select the inside side of the fence, not the outside one. So and so as you can see, the fence is now created. Here will now that the point cloud project data area has been defined, we will see how to create the terrain model from this point cloud data. So to create a terrain model, we'll go to terrain here, additional method. This point cloud data will use this point cloud data tool and we'll create a terrain model for this. So we'll use the existing boundary, the feature definition, filter will set it to none. The edge method will keep a triangle, maximum triangle length of 45 and we'll hit import. We'll now switch off the attached point cloud data. So to switch off this point cloud data display, we'll switch off only the display of this point cloud data. As I said, it is attached from here. So, and it's available to view in all the views, but I want to see, I want to toggle it off on only one view. So I have done this. So now you can see. So to remove the this fence line, we'll again same go in the drawing production tool, place fence, and this the fence is gone. And you can see the terrain model is created using this point cloud survey data, whichever the fence boundary we have given. We had given it earlier. So we are now left with the terrain created by the point cloud data and this terrain which we have attached as a reference in this DGN file. So if you need to display this triangle, I had created this feature definition as a existing boundary. You can turn it to a triangle or something like that to watch the triangle or contours. Even if I done it here as a triangle, so you can see these triangles are incorporated. So it will be a high quality and will large weighted file. So I'll let it be on a boundary only. So now we have defined the project area is this much. So as you can see, there is no survey data in the left portion or the western portion of the projected area. So, and we have the facility to attach the raster image. If you have the raster image is nothing, it's an aerial image which can be contain aerial image that will be used as a as something to create a break line. So this, and then that break line will be incorporated or attached as a feature to this terrain line using add feature tool to this terrain. So first of all, we'll bring that data to our or attach that data. So I have this raster image. As you can see, its form is in TIFF. They are in TIFF format. So I'm using control key. I'm attaching this all at once. Open. The rest of the things is we'll keep it as it is. At this dialog box, we don't need to change the color or geometry or display print, something like that. I'll just hit attach, and then you can see the images are behind the survey data. Why I brought this image, we can, the geographical coordinate system is set, we can open this image from the Bing's map also, as this has a collaboration, Bentley has a collaboration with Bing's map instead of Microsoft or something like that. So I have brought this to just to create the if we have not done the survey on the western part or left something on the western part, so we can create it from here and add it up to our terrain and add that to our terrain model, to this POD terrain model, not in this terrain model. So first of all, I'll create something. I'll create a break line to this. So we'll play using a place smart line tool. Since we do not have the survey data or 3D break lines here, so we are going to create a break line now. So how we'll create a break line, place a smart line. Just remember not to snap to any existing survey. Just place it from little bit away. It's not a good practice to attach, because that is something which is survey data. So here we'll use lines and the sharp join. So before that, I would like to do some settings. I want this line to be on the same no element tablet on a default level, and with color of let's say 2, and the line style will be the same as by default, and the weight will be let's say 4. And now I'll draw the line. So now I had drawn this line, this edge of pavement, you can say, up to here, and I'll hit right click. Now what I'll do, I'll copy this element to the center line of this lane, right, this edge of the road and this edge of the shoulder, then here this edge of the shoulder or shyness, this center line, this edge of shoulder, and road and shoulder. So what we'll do, I'll use a tool called move parallel. It's parallelly I'll move on to move this element. So the original mode will be original. Use active attributes, whatever the attributes are, and I want to make it as a copy. So what do you want? It's asking me select the element. I have selected the element. Now I will shift it to the, let's say it's a shoulder for me. Okay. So, and now it's a center line of this lane. This is the end edge of this road, this lane. Again, a shoulder or shyness, you can say. Again, a shoulder, road edge, center line, road edge, shoulder. So now, if you want to create a ditch or the median cut, then that also can be done. So I'll create a ditch here. Sorry, sorry, I'll create a median cut here first, and then I'm creating a ditch here. Remember not to snap to any element in the survey file. Okay, so now I have created using the raster image. Now I will just display of the view of the raster image in the view one only. So here in one view, I'm attaching it. So now you can see the lines have been created. If I rotated this view, you can see the level of, as our terrain model is here, and the brake line, or sorry, the smart line which we have created, which we will add as a brake line to this terrain, is at this level. So we'll bring this line, add this feature to this level. As I said, we will see now how to project these smart lines to the point cloud data, so they can become a 3D break line that can be used with this point cloud terrain model. So we'll again toggle off the display of point cloud data, this one in the view one. But sorry, before that, we'll select this and create this break lines and create a selection set for this using element selection tool. So as I have selected this line, I'll add this also and this also to our selection set. So now the selection set is created. Now I'll open up the display of point cloud data. I'll toggle it, I'll toggle it on. So I'll select this, I'll toggle it on here. Now you can see the selection set is ready. So to drape them onto the point cloud data, we'll change the workflow and we'll change our workflow to reality modeling, because we need to extract this to this point cloud data. We'll go and extract, and we will use the tool from ribbon extract, and we'll go to this now here. Then extract will go. Actually, we need to snap this element. So we'll go in reality model and we'll use this snap element tool as I have seen, as I have shown here. So setting up this, the method will be used as average depth. We'll see. Yes, and then direction will be in Z direction as let me rotate this view first. As you can see, there is some difference in this view, in this both this line. So we'll use this snap element as there is some depth. So I want this to check to hold depth, and from element only. And I want to set the radius to 1.8. It will search up to radius of 1.8 and up to height of, we are working in metrics. So let's say 1,525 meters up to 1.5 kilometer. Yes, I want to keep the original, use the reality model. Yes. And add the vertices. Yes. And the distance will be 1.5 meters again. So I'll hit data point, and now you can see this element has been added to this point cloud data, or you can say it's draped to this point cloud data. What this input we have given: average depth, check up to average depth on z-axis, depth on axis you can correlate. Then we need to snap this element. So from element, what up to what it will search, it will search up to 1.5 meter, 1.8 meter of radius all over the mm, all direction, you can say. And wherever it will find this point cloud data, it will get attached to that data. So now we'll again toggle off the point cloud data. So we'll go and we'll first of all we'll change our workflow back to OpenRoads modeling. We'll go in attachment tool, point cloud data. We'll toggle it off now. So now you can see we have draped this to this terrain model. And as it is now already selected, I'll hit delete button, it will get deleted. Sorry, our terrain model will also get deleted. So before deleting the terrain model, I'll select this, I'll hit delete, and select this, I'll hit delete. Now we'll we can see now all the entities that we have now draped onto our point cloud data, this survey also and this break line also. Next thing we need to do is to add this break line to the point cloud terrain model so that the triangulation can be done through this also, not only with using that points. And now we need to add this break line to this point cloud data. We can either keep to our workflow to OpenRoad modeling, or we can either change to survey also. So we'll go in terrain again. We'll add this as a feature. We'll select this line, whole lines, similar way. I'll select this and this also. Now I'll add feature this. It's asking me to locate the terrain model. So I'm locating my terrain model. I have already selected this 13 entities or 13 elements. So yes, I want to add this 13 elements to this point cloud terrain model as a break line, and I'll hit accept, accept, and you will see it will process and add this break line to this terrain model. Now the triangulation is done using from this break line also. I will change this feature definition to the existing its existing boundary. I will change it to existing triangles. Now you'll be able to see the triangulation is done using this break lines also, as we have added this as a break line to this break line feature to this point cloud data. Earlier it was not making, it was making using only points. So now, as you can see, we have the two terrain. The one terrain is made up from the point cloud data, and the other one is made up from survey data. So now many times it is necessary to supplement this point cloud data with the field survey data by merging the two together to form a single combined terrain. So now we'll see how to combine this two terrain in a single file. For that, we'll open a different file naming metric tm combined, which is the same empty file, and which has the 3D design file, which is, as we are combining terrain in that, so the seed file has been given to 3D with an appropriate same geographical coordinate system defined to it. As this file is combined 3D seed file, it's an empty file, as I said. So what we'll do, we'll bring that two terrain which we have created recently. One we have created, one was already there. So in this point cloud data, we have this terrain created from point cloud, and this terrain created from the survey. The attachment method will be same, coincident world. And now you can see the terrain has been referenced. This terrain is already only referenced in this file, new file. So to attach this file or to create the complex terrain, we'll go to a terrain additional method, create complex terrain. So the software know there are two types of terrain in this file. So one is created and named as point cloud. And another one is created and named as an existing ground. So we will attach, will the point cloud data will be our primary data, and our existing ground will be appended. It's not appended. We'll use it as a merge. We want to merge this data, existing ground data, to this point cloud data, as we need to supplement this point cloud data with the field survey data. So this is our field survey data. The feature definition will keep as a, let's say, existing triangles. Later on, we can change the same, and the name will give it as a combine from point cloud and from field survey. When hit finish, it will process. What that merge option will do, where there is overlapping data, the existing round will take priority. That's why we have done that as a merge. And we can observe a complex terrain here now. And here we can see in the area where there was the existing ground, there is a terrain model for which uh, for that, and here is a terrain model from point cloud data. This all created terrain model from point cloud data, and here is from ground. So it is representing as a ground. That's why it's created from the field survey. Both are now combined and created as a one, and this file contains a combined terrain model, where this file contains individual terrain models. So that's it from my side. We would, now we would be happy to hear from you anything. Please reach out to us for any suggestions, queries, or topic you would want to discuss. See you next week. Take care.